We are going to start now lecture 6 of chapter 9 class 11th mathematics, sequence and series. So in this lecture we will talk about the geometric progressions. So we are talking about a sequence whose elements are A1, A2, A3 and so on up to An, and it is called a geometric progression if each term in this sequence, the first condition we have that each term ai it is not equal to 0 for I is equal to 1, 2 so on up to n, and second we are saying that ak plus 1 over ak that is equal to r, that is ratio of two consecutive terms, it is constant. When we were talking about AP, we were writing that a n plus 1 minus a n, the difference of these two terms, it is a constant. In this case we are saying the ratio of the two terms it is constant, and this value of k we are saying it is for all natural numbers, and this constant ratio that we have, this r, it is called the common ratio. In this case it was called common difference, now over here it is called common ratio. And if this sequence is satisfying these conditions, then these are said to be in geometric progression. We write in short form, we have written it as GP. Now when we are talking about the nth term of this GP, we are saying the first term it is denoted by A, common ratio is denoted by R, the nth term it is denoted by Tn. So based upon this, the first question we have is show that the progression this is a GP, write down its first term and the common ratio. So we have to prove that this is a GP. So what we are going to do, it is 18 over 6 we are saying that is equal to 54 over 18, that is equal to 162 over 54. All these values we are saying they have, I think 18 over 16, then 15 over 18, then 162 over 84. All these values, these are equal to a constant number that is 3, and this is the common ratio that we have, and the first term of this GP it is 6. The first term of this GP it is 6. Next is show that the progression, this progression is given to us, it is a GP, and we have to write its first term and the common ratio. Now again the first term of this GP it is minus 16. Now to calculate, first thing we are saying we have to show that it is a GP. So we are calculating 4 by minus 16, that is equal to minus 1 by 4, that is equal to 1 by 4 by minus 1, and all these values are equal to minus 1 by 4, and this is the common ratio that we have. So we are saying the common ratio in this case it is minus 1 by 4, and the first term we have it is minus 16. Next is show that this progression is a GP, write down its first term and find the common ratio. So again to prove that these terms they are in GP, we are saying we have minus 1 by 3 upon 1 by 2, that is equal to minus 2 by 3. Next 2 by 9 divided by minus 1 by 3, that is equal to 2 by 9 into 3 by minus 1, that is equal to minus 2 by 3. Similarly 2 by we are saying the next term we have it is minus 4 by 27 into 9 by 2, that is equal to minus 2 by 3. So in all these cases the answer we have it is minus, the ratio we have it is minus 2 by 3. So the value of r we are saying it is minus 2 by 3. The first term we have over here it is 1 by 2, and this ratio it is fixed over here. This ratio of these two consecutive terms it is fixed over here. So we are saying it is a geometric progression whose first term is 1 by 2 and common ratio is minus 2 by 3. Next is show that the sequence Tn is equal to this, it forms a GP. So we are writing the general term is given, Tn is equal to 2 into 3 raised to the power n. Now what is Tn plus 1, that is equal to 2 into 3 raised to the power n plus 1. Now ratio of these two, it is, we are talking about Tn plus 1 over Tn, that is equal to 2 into 3 raised to the power n plus 1 over 2 into 3 raised to the power n, and the answer we have it is 3. So we are saying that ratio of these two terms, Tn plus 1 over Tn, the ratio of these two terms, it is equal to 3 and it is a constant number. So the common ratio we have in this case, it is the common ratio R we have, that is equal to 3. Now another thing we have to do is we have to calculate the first term. So the first term T1 we are saying that is 2 into 3, that is equal to 6. So we are saying the first term we have it is 6 and the common ratio we have it is 3. Next is geometric series. So we are saying if A1, A2, A3 so on up to An is a GP, then the sum of these terms A1 plus A2 plus A3 so on An so on is called the geometric series. This is just the similar case as we were talking in case of arithmetic series. We are saying we are taking the sum of all these numbers that are forming the GP. So we are saying that the sum will be finite or infinite corresponding to the GP has finite or infinite elements. So the next thing we have is the general term of a GP. So as in case of the AP, we have seen that the general term was Tn is equal to A plus n minus 1d. Now we have to find this kind of formula for a GP. So we are saying suppose we have a GP whose first term is A. This is the first term we are writing, it is T1. And the common ratio we have it is, this is the common ratio R. So the value of T2 will be A into R. The value of T3 will be A into R because it is being given that it is a GP. So we will have T2 over T1 is equal to R. So this implies us T2 is equal to R times T1. We have T3 by T2 is equal to R. So this implies us T3 is equal to R times T2 and so on. So what we are saying, it is T4 is equal to A, this value we have it is AR square. We are saying it is AR square into R. So that is equal to AR cube. Now if we continue like this, we will obtain that Tn is equal to AR raised to the power, I think it is AR raised to the power n minus 2 into R. It is 4 over here, the power is 2, it is 3 over here, the power is 1. So the answer we are writing that the general term we have it is AR raised to the power n minus 1. So this is the formula we are saying, that this is the formula for the general term of an GP. This is the formula for general term of a GP. Next is find the 10th term and the general term of this progression. So the first term we have over here, the value of A we have it is 1 by 4. Now if we are looking at the terms over here, we have the value minus 1 by 2 into 4, that is equal to minus 2. Next 1 into minus 2, that is equal to minus 2. Then minus 2 by 1, that is equal to minus 2. Then 4 by minus 2, that is equal to minus 2. So we are saying the ratio of all consecutive terms that we have, that is equal to minus 2. So clearly this is a GP. And the common ratio we have it is equal to minus 2. Now we have to write the general term. So the value of Tn, that is equal to A R raised to the power n minus 1, that is equal to 1 by 4 into minus 2 raised to the power n minus 1. So if we substitute, we want to find the value of T10, it is 1 by 4 into minus 2 raised to the power 9. So the answer we obtain it is minus 512 by 4, that is equal to minus 128. So this is the 10th term and this is the general term of this GP. Next is show that this progression is a GP, find its 5th term. So to prove that it is a GP, we are taking the ratio of these terms. So first ratio we have it is root 2 minus 1 by 2 root 3. This is the value of T2 by T1. Now next we have is T3 by T2. So it is 3 minus 2 root 2 by 12 into 2 root 3 by root 2 minus 1. So if we look at these terms, we are saying this 2 and this term gets cancelled. So it is equal to 3 minus 2 root 2 by root 2 minus 1, and we have over here it is square root 3 by 6. So this 6 we can write it is 2 into 3. So this root gets cancelled over here and we are at with this root 3 because we are comparing this answer over here. Now look at this value. We are getting it is 3 minus 2 root 2 by root 2 minus 1, and we have over here 1 by 2 root 3. Now if we rationalize this term, we are writing it is root 2 plus 1 divided by root 2 plus 1. The answer we obtain, we multiply these terms, we are getting 3 root 2 minus 4 plus 3 minus 2 root 2 divided by 2 minus 1 into 1 by 2 root 3, and this is equal to square root 2 minus 1 divided by 2 root 3, and this is what is the value of T2 by T1. Similarly, if we calculate the ratio of these two terms, we will obtain the same answer, that it is minus root 2 minus 1 by 2 root 3. So these calculations, these are shown over here. You will obtain the same answer. So we are saying that the common ratio we have over here, it is root 2 minus 1 by 2 root 3, and the value of first term we have it is 1. Now we have to calculate the fifth term. So T5 is equal to A into root 2 minus 1 by 2 root 3. We are talking about this is 5, so power we will have it is 4. So this is equal to root 2 minus 1 raised to the power 4 divided by 144, and when you simplify this term, you will obtain the final answer in this form, that it is 17 minus 12 root 2 divided by 144. So this is the final answer we are obtaining in this case. Next is which term of the GP, this GP is given to us, is 131,072. So we are talking about the value of A, we have it is 2. It is given that it is a GP, so the value of R we are saying it is 8 by 2 is equal to 4. Suppose the nth term Tn, that is equal to 131,072. So it is equal to 2 into R raised to the power n minus 1. So it is 2 into 4 raised to the power n minus 1. Now this implies us that 4 raised to the power n minus 1 is equal to 65536. This implies us 4 raised to the power n minus 1 is equal to 4 raised to the power 8. So this implies us as n minus 1 is equal to 8. So this gives us n is equal to 9. So we are saying that the ninth term of the GP is this. Next is which term of this GP is 1 by 729 root 3. So again in this GP we are saying we have the value of A is equal to root 3. The value of R we have it is 1 by square root 3 divided by root 3. Answer we get it is 1 by 3. Now we are talking about Tn, that is equal to 1 by 729 root 3, that is equal to AR raised to the power n minus 1. So we are writing that 1 by 729 root 3, that is equal to square root 3 into 1 by 3 raised to the power n minus 1. So when we multiply these numbers, we will obtain that 1 by 729 into 3, that is equal to 2187. This root 3 into root 3 will become 3. That is equal to 1 by 3 raised to the power n minus 1. And this value is equal to 1 by 3 raised to the power 7. Now comparing both these results, we will obtain n minus 1, that is equal to 7. So this implies us n is equal to 8. So this gives us that n is equal to 8. So we are saying that the 8th term of this GP is 729 root 1 by 729 root 3. Next we have is, if the 4th and 9th term of the GP are 54 and 1312, that is, we are saying that T4 is equal to 54 and T9 is equal to 13122. We have to find the GP and also its general term. So we are writing that AR raised to the power 3, that is equal to 54, and AR raised to the power 8 is equal to 13122. Now if we divide both these values, we will get R raised to the power 5 is equal to 13122 divided by 54, that is equal to 243. So R raised to the power 5 is equal to 3 raised to the power 5, and this implies us that the value of R we have, that is equal to 3. The value of R we get, it is equal to 3. Now if we substitute this value of R in one of these equations, we will obtain that A into 3 raised to the power 3 is 54. So this implies us that the value of A we have, it is equal to 2. So now what we have obtained, A is equal to 2, R is equal to 3. So the required GP, we are saying find the GP and find its general term. So the GP we have, it is 2 into 3 6, then 18, then 54 and so on. And if we have to write the general term Tn, the answer we will have, it is AR raised to the power n minus 1. It is 2 into 3 raised to the power n minus 1. So this is the general term of this GP. Next is the first term of the GP is 1, that is the value of A is given to be 1, and the sum of its third and fifth term is 90. It is given that T3 plus T5, that is equal to 90. So if we are talking about T3, the value of T3 we are saying it is 1 into R raised to the power 2 plus 1 into R raised to the power 4, it is given to be equal to 90. So we are getting the equation R raised to the power 4 plus R raised to the power 2 minus 90 is equal to 0. So if we substitute R square is equal to T, we will have T square plus T minus 90 is equal to 0. Now on solving this, we will obtain the value of T is minus 10 and 9. We are having R square is equal to T. So clearly we are saying we have real values of R over here. So we are saying that T cannot be equal to minus 10. So we have R square is equal to 9, and this implies us R is equal to plus minus 3. So the common ratio we can have over here, it is plus minus 3. In both these cases, we will have this condition will be satisfied. Next is the 4th, 7th and 10th term of a GP are A, B, C respectively. We have to prove that B square is equal to A, C. So we are talking about T4 is equal to A, T7 is equal to B and T10 is equal to C. Now the values of these terms we have, it is, suppose we are writing the first term, it is A, then we are writing it is R raised to the power 3, this is A R raised to the power 6, this is A R raised to the power 9. Now if we substitute the value of, we try to calculate the value of AC, we are talking about the value of A into C, the answer we have, it is A square into R raised to the power 12. We are talking about the value of AC. We are saying its value is equal to this, and this is equal to A R raised to the power 6 whole square, and this is equal to B square. So we are saying that what we have obtained, that B square is equal to A C. So we are saying that B square is equal to A C. Next is, if A, B, C are the 3 consecutive terms of an AP and X, Y, Z are the 3 consecutive terms of a GP. We have to prove this result. Now if A, B, C are three terms of an AP, it means B minus A is equal to C minus B, and this value is equal to say we are saying it is D, and it is given that X, Y, Z, these are the three terms of a GP. So from this we obtain that Y over X is equal to Z over Y, that is equal to R. Now we have to prove this result. We are talking about X raised to the power B minus C into Y raised to the power C minus A into Z raised to the power A minus B. We want to calculate the value of this term. So if we look at this value A minus B, we are getting Z raised to the power minus D. Now this value B minus C, we have it is minus D, so it is X raised to the power minus D. Now we require the value of C minus A. Now we have B minus A is equal to D, C minus B is equal to D. Now if we add both these equations, we will obtain C minus A is equal to 2D. So from this result we are getting Y raised to the power 2 times D. Now further we have, look at these two values. From these two values we can write Y square is equal to X into Z, and if we substitute this value of Y square over here, we will obtain this is equal to X raised to the power minus D, then XZ raised to the power Y square, in place of this we have D over here, and Z raised to the power minus D. So the final answer we are getting, it is X raised to the power minus D, X raised to the power D, Z raised to the power D, Z raised to the power minus D, that is equal to 1, and this is what we have to prove. Next is, if A, B, C, D are in GP, we have to prove this result. So if A, B, C, D, these are in GP, what we have is, the first term we have it is A, then B is equal to A into R, if R is the common ratio, then C is equal to A R square, and D is equal to A R cube. These are the terms we are talking about. Now we have to prove this result. Now if we substitute these values over here, I am talking about the left hand side. If I substitute these values over here, we will get A square plus A square R square plus A square R raised to the power 4 into, it is A square R square plus A square R raised to the power 4 plus A square R raised to the power 6. So this is equal to, if we write A raised to the A square common from both these terms, it is 1 plus R square plus R raised to the power 4. We are taking R square common, we are left with is 1 plus R square plus R raised to the power 4. So we are getting it is A raised to the power 4 R square into 1 plus R raised to the R square into R raised to the power 4 whole square. Now when we are talking about the right hand side, we are saying it is AB. A into B means we are saying A square R, then it is BC, it is A square R cube, and then it is CD, and it is A square R raised to the power 5, and it is whole square. So if we take A square R common, we will have A square R whole square into 1 plus R square plus R raised to the power 4 whole square, and clearly both these values, these are equal to each other. Both these values, we are saying RHS and LHS, both these are equal to each other, hence this result is proved. Now in this question, it is being given that if A, B, C, D are in GP, we have to prove this result. So if A, B, C, D are in GP, then we have this A, then common ratio if it is R, then B is equal to AR, C is equal to AR square, and D is equal to AR cube. Now if we substitute the values in the left hand side of this equation, we will have AR minus AR square whole square plus AR square minus A whole square plus, it is d minus b, so it is ar cube minus ar whole square. Now from this first term we can write a common, and we are having a square into r minus r square whole square. From this next term we can write a common, so it is plus a square into r square minus 1 whole square. And from the next term again we are taking a common, so it is a square into r cube minus r whole square. So if we write a square common from all these terms, we are left with this r minus r square whole square plus r square minus 1 whole square plus r cube minus r whole square. Now if we apply the formula over here, we are having a square into, it is r square plus r raised to the power 4 minus 2r cube, then it is plus r raised to the power 4 plus 1 minus 2r square, then it is plus r raised to the power 6 plus r square minus 2r raised to the power 4. Now on solving all these values, we will obtain this is a square into r raised to the power 6 minus 2r cube plus 1, and this is equal to a square into 1 minus r cube raised to the power 2. And if we calculate the value of this term, it is a minus d whole square. We will have a minus, the value of d we have, it is a r cube, and it is whole square over here, so we are getting it is a square into 1 minus r cube raised to the power 2, and both these values, these are equal. So we obtain that LHS is equal to RHS, and this is what we have to prove. Next is, if pth, qth and rth term of a GP are a, b, c respectively, then we have to prove that a raised to the power q minus r into b raised to the power r minus p into c raised to the power p minus q is equal to 1. So we have value of this is pth term is a, so we are writing a is equal to, suppose the first term it is a, common ratio it is r, it is p minus 1. We have b is equal to a r raised to the power q minus 1, and c is equal to a r raised to the power r minus 1. Now if we substitute these values over here, we will obtain, we are talking about this result, we are saying in left hand side when we substitute these values, we will obtain a raised to the power, we are having a into r raised to the power p minus 1 whole raised to the power q minus r. Similarly next term and similarly next term. On solving this, what we will obtain is that a raised to the power q minus r plus r minus p plus p minus q, and r raised to the power, it is p minus 1 into q minus r, then it is q minus 1 into r minus p, and then it is r minus 1 into p minus q. Now look at these values over here, these values, this q gets cancelled, p gets cancelled and r gets cancelled, so this a term is being removed, and what we are left with is r raised to the power, it is pq minus pr minus q plus r. Then the next term we have is plus qr minus pq minus r plus p, and the last term we obtain it is plus rp minus rq minus p plus q. Now again this q gets cancelled, this r gets cancelled, this p gets cancelled, then rq gets cancelled, we are having this rq, this gets cancelled with this rq, and pq gets cancelled, this pr gets cancelled, we have r raised to the power 0, that is equal to 1, and this is equal to right hand side of this equation. Next is, if the first and the nth term of the GP are a and b. So first term is a and nth term we are saying it is b, so b is equal to a, common ratio if it is r, so it is n minus 1. and P is the product of its first n terms. So if the first term is A, second term is AR, next term is, this is we are multiplying, AR square, so on up to AR raised to the power n minus 1, and we are saying that the product of all these terms is equal to P. So we are saying there are total n terms over here. So what we obtain from this is that A raised to the power n into R raised to the power 1 plus 2 plus so on up to n minus 1 is equal to P. This is A raised to the power n, R raised to the power. These values are there. So it is 1 by 2 into n minus 1 is equal to P. Now look at this value. We have B over A. We are talking about the value of R raised to the power n minus 1. We have its value is B over A. Now we can substitute this value over here. We are having A raised to the power n, R raised to the power n minus 1 raised to the power n by 2 is equal to P. So we can substitute this value over here. We will obtain A raised to the power n, B raised to the power n by 2 over A raised to the power n by 2 is equal to P. This becomes A raised to the power n by 2. So what we obtain on solving all this is that AB raised to the power n is equal to P square, and this is what we have to prove. Next is the m plus nth and m minus nth term of GP are P and Q respectively. So suppose we are saying the first term it is, we are saying first term is A, the common ratio is R. So what is being given to us is that P is equal to A R raised to the power m plus n minus 1. Q is equal to A R raised to the power m minus n minus 1. Now if we divide both these equations, we will obtain P by Q is equal to R raised to the power m plus n minus 1 minus m plus n plus 1. This one gets cancelled and this m gets cancelled, and we are getting it is R raised to the power 2n. So the value of R that we obtain, that is equal to P by Q raised to the power 1 by 2n. Now we have to calculate the value of the mth and the nth term. So when we are talking about the mth term, the answer we obtain, that is equal to AR raised to the power m minus 1. This is equal to, now if we add and subtract n to it, we will obtain it is AR raised to the power m plus n minus 1 into 1 by R raised to the power n. Look at this value, A into R raised to the power m plus n minus 1. This value is P. And the value of R raised to the power n, look at this term over here. We have R raised to the power n is equal to P by Q square root. So we are having over here the value P raised to the power 1 by 2 over Q raised to the power 1 by 2. So the answer we are getting it is PQ square root, and this is the first part that we have to prove. Now the second thing we have to calculate is the nth term. We are talking about Tn. We are writing it is AR raised to the power n minus 1. This is equal to AR raised to the power m plus n minus 1 into 1 by R raised to the power m. Now again, AR raised to the power m plus n minus 1, this is equal to, this first value we are saying, this is equal to P into power, we have m over here, and the value of 1 by R we have it is P by Q raised to the power 1 by 2 n. So on solving this, we will obtain the final answer that we obtain in this case, it is equal to P into Q by P raised to the power m by 2n, and this is the answer that we have to prove. Next is the pth, qth and rth term of an AP as well as those of GP are A, B, C respectively, and we have to prove this result. So it is being given that A is equal to AR raised to the power P minus 1, B is equal to AR raised to the power Q minus 1, and C is equal to AR raised to the power R minus 1. Now if we substitute these values in the left hand side of this equation, we obtain LHS, that is equal to a raised to the power b minus c plus c minus a plus a minus b. From the first, second and third term we will obtain this, and the powers of r that we will have, it is b minus c into p minus 1, then plus c minus a into r minus 1, and last is a minus b into q minus 1. And when you multiply all these terms, open all these terms, the answer you will obtain, that is equal to 1, and this is what we have to prove, and we are saying this is equal to right hand side of this equation. Now next we have is x, 2y and 3z are in AP, where the distinct number x, y, z are in GP, then find the common ratio of the GP. So it is being given that these three numbers, these are in GP. It means we are writing that the first number, if it is x, then y is equal to x into r and z is equal to x into r square. Now it is being given that x, 2xr and 3xr square, these are in, these three numbers, these are in AP. If these are in AP, it means we have 2xr minus x is equal to 3xr square minus 2xr. So the value of x, we are saying it is not equal to, one condition we are getting from this is x into 2r minus 1, that is equal to x into 3xr into 3r minus 2. These two values are equal to each other. So one condition we are getting from this is either x is equal to 0, or the second condition we are getting is that 2r minus 1, that is equal to 3r square minus 2r. So this implies as 3r square minus 4r plus 1 is equal to 0. When you solve this equation, what we will obtain? This will imply us that the value of r, this is r minus 1 into 3r minus 1 is equal to 0. So this implies us r is equal to 1 by 3, or r is equal to 1. Now look at the conditions over here. First thing is that x, y, z are in GP. If x, y, z are in GP, it means x, y and z, none of them can be equal to 0. So it means this condition cannot hold. Now next we have is that if these three values, these are not equal to each other, it means we are saying that r is equal to 1 is not possible. So the common ratio of this GP is 1 by 3. We are left with this answer, that the common ratio of this GP, it is 1 by 3. Now in this next question, it is being given that in a GP of positive terms, positive term means the first term it is positive, a we are saying it is greater than 0, there is a common ratio r over there and all the terms they are positive. If any term is equal to the sum of the next two terms, it means it is given that Tn is equal to Tn plus 1 plus Tn plus 2. Then show that the common ratio of the GP is 2 sine 18 degree. So if we substitute the values over here, it is ar raised to the power n minus 1 is equal to ar plus ar raised to the power n plus 1. Now if we take ar raised to the power n minus 1 common from all these terms, it is n over here. So we are left with this is n and ar, and this term we are left with this r square. Now one thing is clear that a is not equal to 0, so both these terms gets cancelled. The value of r that we have, it is not 0, so both these terms gets cancelled. So what we are left over here is r square plus r minus 1 is equal to 0. So the values of r that we obtain, that is equal to minus 1 plus minus square root of 5 by 2. Now if we are talking about the value r is equal to minus 1 plus square root of 5 by 2, this is greater than 0, and if we are saying r is equal to minus 1 minus square root of 5 by 2, this is less than 0. So we are not talking about this case, so we are having r is equal to, we are left with r is equal to minus 1 plus root 5 by 2, and we can write this is equal to 2 into root 5 minus 1 by 4, and we know that we have already studied in our second chapter of trigonometric functions that this is the value for 2 sine 18 degree. This is the value of 2 sine 18 degree. So we are obtaining this answer. Next is, if P, Q, R are in AP, prove that Pth, Qth and Rth term of any GP are in GP. So it is being given that P, Q, R are in AP. So what we have is that Q minus P is equal to R minus Q. Now suppose we are talking about a GP whose first term is A and the common ratio is R. Then the pth term of this GP is A R raised to the power P minus 1. Qth term of this GP is A R raised to the power Q minus 1. And Rth term of this GP is A R raised to the power R minus 1. Now we have to prove that these three terms we are saying these are in GP. So if we calculate the value of A R raised to the power Q minus 1 over A R raised to the power P minus 1, the answer we obtain it is R raised to the power Q minus P. If we calculate the ratio of these two terms, it is A R raised to the power R minus 1 over A R raised to the power Q minus 1. The answer we are obtaining R raised to the power R minus Q. Look at this value, R minus Q, that is equal to Q minus P. So what we obtain is that TQ by TP, that is equal to TR by TQ. So we obtain that these three terms that we have over here, these are in GP. These form a GP. Next is, let S be the sum, P be the product and R be the sum of the reciprocals of the three terms of a GP. So we consider that let the three terms of the GP, they are A by R, A and AR. Now it is being given that the sum of their reciprocal, that is A by R plus A and AR, it is S is the sum, P is the product A by R into A into AR, and R be the sum of their reciprocals, that is R by A plus 1 by A plus 1 by A R. So we have to prove that P square R cube is equal to S cube. So look at this value, this R get cancelled, we are left with this P is equal to A cube. Now from this first term we have S is equal to A into 1 by R plus 1. From this last equation we have the value of R is equal to 1 by A into 1 by R plus 1. So if we substitute the value of this term, we are saying this implies us that 1 by R plus 1, that is equal to AR, and if we substitute this value over here in this equation, we obtain S is equal to, the value of S we obtain, that is equal to A square R. Now the value of P we have, it is A cube. Now we have to eliminate A from these two equations. So what we are going to do is, we are going to write P is equal to A cube, S over R is equal to A square. If we square this equation and if we cube this equation, this will imply us P square is equal to A raised to the power 6. This is S square over R, S cube over R cube is equal to A raised to the power 6. So from both these equations we obtain that S cube is equal to P square R cube, and this is what we have to prove. Next is, for A, B, C to be in GP, what is the value of A minus B over B minus C? So if A, B, C these are in GP, we have B over A is equal to C over B, and this ratio is constant, it is equal to some value R. Now from this equation, if we substitute the value of A, if we calculate the value of A, we will have it is B over R. If we calculate the value of C, it is R into B. And we substitute these values in this given equation, A minus B. So it is B over R minus B divided by B minus R into B. So it is GP, so clearly B cannot be equal to 0. So what we obtain is that 1 minus R over R divided by 1 minus R. This is the value we are getting. Now 1 minus R and 1 minus R gets cancelled. It is 1 minus R get cancelled and we are left with is 1 by R. So we are saying the value of this term we have, it is equal to the value of R we have over here. So the value of 1 by R, either we have it is B by C or A by B. So these are the values of this term over here. Next is, if A, B, C are in GP and these values are equal, we have to prove that X, Y, Z they are in AP. Now A, B, C are in GP, so this thing implies us that B by A is equal to C by B. So this implies us B square is equal to AC. And it is being given that A raised to the power 1 by X is equal to B raised to the power 1 by Y is equal to C raised to the power 1 by Z. So suppose we are saying this value is equal to K. So we obtain A is equal to K raised to the power X, B is equal to K raised to the power Y, and C is equal to K raised to the power Z. Now if we substitute these values in this equation, what we obtain is, it is K raised to the power 2Y is equal to K raised to the power X plus Z. So this thing implies us that 2Y is equal to X plus Z. So this implies us that Y is arithmetic mean between X and Z. So this implies us that X, Y, Z are in AP. Next is, if A, B, C are in AP, B, C, D are in GP, and 1 by C, 1 by D and 1 by E are in AP, we have to show that A, C, E are in GP. So A, B, C are in AP. This implies us that 2B is equal to A plus C. B, C, D are in GP. This implies us C square is equal to B into D. And 1 by C, 1 by D and 1 by E are in AP. This implies us that 2 by D is equal to 1 by C plus 1 by E. So this implies us that 2 by D is equal to C plus E over C E. Now this equation gives us the value of D, that is equal to 2CE divided by C plus E. Now if we substitute these values in this second equation, we require the answer relation between A, C and E. So in place of D we substitute this value, and in place of B we substitute the value from this equation. We will obtain the relation between A, C and E. So we have C square is equal to A plus C by 2 into 2CE by C plus E. So this 2 gets cancelled and this C gets cancelled over here. So what we are left with is, this implies us that C by E is equal to A plus C divided by C plus E. Now if we cross multiply these terms, we obtain C square plus CE is equal to AE plus EC. Again this EC get cancelled and we are left with this C square is equal to AE. This implies us that C by A is equal to E by C. So this thing implies us that A, C, E are in GP. Next we have is, if P, Q, R are in GP and the equation Px square plus 2Qx plus R is equal to 0 and Dx square plus 2Ex plus F is equal to 0 have a common root, we have to show that these three terms are in AP. So we are given that P, Q, R are in GP. So this thing implies us that Q square is equal to P into R. Now if we solve this first equation, we will obtain the value of x is equal to minus b plus minus square root of 4q square minus 2pr divided by 2p. Now the value of q square is equal to pr. So by simplifying this, we will obtain this is minus 2q by. So it means that this root, it is the root of this second equation. So if we substitute this value in the second equation, we will obtain d into minus q by p square plus 2e into minus q by p plus f is equal to 0. Now if we simplify this, we obtain it is dq square and then it is minus 2epq plus fp square is equal to 0. So this implies us that d by, we are dividing it by q square and p is there. So we get d by p minus 2e by q plus fp by q, that is equal to 0. Now we have these terms. Now by rearranging these terms, we can obtain that d by p plus f by r, that is equal to 2e by q. We are obtaining this result, and this result proves that d by p, e by q and f by r, they are in AP. Next is find all sequences which are simultaneously AP and GP. So suppose we are talking about the sequence A1, A2, so on up to AN, and we are saying that this sequence is simultaneously AP as well as the GP. So if we consider any three terms, we are talking about AN plus 1, that is equal to AN plus 2 if it is an AP. And if we are talking about that this is also a GP, then and we substitute the values over here. Suppose the first term is A, common ratio of the GP it is R. Then what we will obtain from this is 2AR raised to the power n, that is equal to AR raised to the power n minus 1 plus AR raised to the power n plus 1. We are saying from the condition of AP we are getting this result, and from the condition of GP we are getting this result. Now A, clearly it cannot be 0 because it is a GP, so the first term cannot be 0. So what we are left with is that 2R raised to the power n, that is equal to R raised to the power n minus 1 into 1 plus R square. So what we obtain is that 2R is equal to 1 plus R square. So the equation we obtain is that R square minus 2R plus 1 is equal to 0. So this implies us that R minus 1 whole square is equal to 0. So this implies us R is equal to 1, and R is equal to 1 means that it is a GP with common ratio 1, so it is A and so on. So this implies us that it is a constant sequence. It is a constant sequence. Next is if the pth, qth, rth and sth term of a AP are in GP, we have to prove that these three values are in GP. So if we talk about the pth, qth and rth term, we are saying Tp is equal to A plus P minus 1D, they are in AP. Tq is equal to A plus Q minus 1D. Tr is equal to A plus R minus 1D, and Ts is equal to A plus S minus 1D. Now it is being given that these four terms, they are in GP. So if these four terms are in GP, it means if the first term we are considering it is A, this second term is AR square, this third term is AR cube, and this term it is AR raised to the power 4. Now if we subtract these two equations, we obtain that Q minus P into D, that is equal to A into 1 minus R. If we subtract the next two equations, we will obtain Q minus R into D is equal to A R into 1 minus R. If we subtract next two equation, it is R minus S into D is equal to A R square into 1 minus R. Now from all these conditions, now look at this equation, it is Q minus R into D is equal to this value. Now if we square this equation, we obtain Q minus R square D square. Why we are squaring? Because we require these three terms to be in GP. It means we have to prove that Q minus R square is equal to P minus Q into R minus S. So we are squaring these terms. We are getting this is equal to A square R square into 1 minus R square. So it is Q minus R square is equal to, we are writing it is A by D into 1 minus R. One term we are writing it is this. Second we are writing it is A by D R into 1 minus R square. Now look at these two terms. It is A over D 1 minus R. This is value of Q minus P. And look at this term. This is ratio of these values. So the answer we obtain in this case, that is equal to R minus S. So by combining these results, we are getting that Q minus R square is equal to P minus Q into R minus S. So this proves that these three terms, these are in GP.